So in this presentation, we will learn about the next term called valency in the lesson atomic structure. Valency is defined as a combining capacity of an atom. We will discuss with a few slides the term valency. Now let us consider helium atom. So atom is in a constant struggle to attain a stable configuration. What is stable configuration? Helium is said to have a stable configuration. That is, helium has only one shell. If the element or an atom has just one shell, then if it has two electrons, then it is said to have a stable configuration. So here helium has two electrons, that is atomic number is 2, that is z equal to 2. So we have two electrons in the K shell and it is said to have a stable configuration because it has two electrons in its outermost or with the one and only shell, which is the K shell. Whereas the other atoms which have more than one shell, that is one orbit, that is 2 or 3 shells, then it will have a stability if it has 8 electrons in the outermost shell, which is the valence shell. That is called as octet configuration. So if an atom has more than one shell, if the valence electrons are equal to 8, then it is said to have an octet configuration, which means 8 electrons in its outer shell, which is valence shell. If the valence electrons are equal to 8, then it is said to have a stable configuration. So here we have neon represented by the symbol Ne. So the atomic number is 10. So first shell K shell has 2 electrons and 8 in the second shell, which is the L shell, the outermost shell, which has 8 electrons. So it is said to be stable. So not only helium and neon, we have few more elements that are very stable, which has this octet configuration. So they are neon, argon, krypton, xenon. So if you observe the electronic configuration, the last shell is complete with 8 electrons, which means they all have a stable configuration or octet configuration. So they are said to have the valency 0. That means they will not be ready to lose this valence electrons or gain any extra electrons which will affect the stability. So they already are stable, so they are said to have the capacity to combine, that is 0. So it is valency of inert gas is 0. So they are called as 0 group elements. They don't combine with other atoms, so they are called inert gases. So they are all they don't form any molecules. There are few exceptions, but they are generally monoatomic molecules. They don't form a bond with other atoms. They don't form molecules. They exist as mono. Mono means single atom, as they already have octet configuration. But all other atoms are in constant struggle to attain this stability. Suppose if you consider hydrogen with Z equal to 1, that is atomic number is 1 with 1 electron. So we know that helium is stable with 2 electrons. So hydrogen will try to acquire the stability of helium by sharing or accepting 1 electron from other atoms. So hydrogen's valency is 1. So the term valency is nothing but the number of electrons which the atom tries to share, accept or donate in order to acquire this kind of stability, that is called as octet configuration. So we have an example here with chlorine, Z equal to 17, that is atomic number is 17. So electronic configuration here it is 2, 8, 7. K shell with 2 electrons, L shell with 8 electrons, and then M shell with 7 electrons. So can you just guess what is the number of electron that it requires to in order to acquire 8? Yes, it is 1. So it is in shortage of 1 electron to complete its octet, that is 8 valence electrons. So the valency of chlorine is 1. So it is a very highly reactive non-metal, or it is also called as halogen, salt producers. It is reactive because it has just valency 1. It is in shortage of 1 electron and it has just 7 in its valence shell, that is 7 valence electrons. So 1 is its combining capacity or its valency. Now we have one more example, potassium represented by the symbol K, whose atomic number is 19. So the electronic configuration is given here. K has 2 electrons, L has 8 electron, M shell has 8 electron and N shell with 1 electron. So 2, 8, 8, 1 is electronic configuration of potassium, which is represented by the symbol K. So what is the symbol of potassium? It is K, Z equal to 19. So valency is 1. How? Now we know that the last shell, valence shell, has only 1 electron here for potassium. It needs 7 electrons in order to complete its octet configuration. But do you think that any atom will be ready to donate 7 electrons? Not at all. So potassium will be happy to leave out this, that is to give this one electron in order to acquire a stability of 8 in its previous shell. So it will acquire the octet configuration by donating this one electron. So again, by donating this one electron, it will combine with other atoms. So the combining capacity is 1. So we should understand that if the valence electrons are less than 4, 4 is the standard number that you have to remember. If the valence electron in an atom is less than 4, then that will be its valency. That is, the atom will donate those number of electrons. If it is 2, it will donate. If it is 3, it will donate. If it is 1, it will donate. So that will be its valency. But whereas if the valence electrons are more than 4, then it is 8 minus that number will give its valency. So here we have 7. So 8 minus 7 is 1 is the valency of chlorine. So as you deal with more examples, you will have a better idea. Now we have this electron transfer that is called as bond formation between potassium and chlorine, which we discussed in the earlier slides. So here we have the Lewis dot representation where we have these elements potassium K, chlorine Cl, which are represented here with dots. These dots are the electrons which are present in the valence shell. They are called valence electrons. So potassium has 1 valence electron, chlorine has 7 valence electrons. So potassium is donating 1 electron to chlorine. So what happens to potassium? It acquires a positive charge because it donates a negative charge electron, and chlorine accepts 1 electron, so it acquires a negative charge. So these are called ions, atoms with a charge. Why do they acquire a charge? How do they acquire a charge? By donating or accepting electrons, they acquire a charge. So a bond is formed which is called as ionic bond between these two elements, potassium and chlorine, or two atoms, potassium and chlorine, which has the valency 1. Both potassium and chlorine has valency 1, combining capacity is 1, and so an ionic bond is formed by the transfer of electron from potassium to chlorine. So here we have an oxygen atom where the Z is equal to 8. So we have 6 valence electron, that is 2 in the K shell and 6 in the valence shell, that is L shell. So it is in shortage of 2 electrons in order to acquire the neon gas stability. So we know that neon is having 8 valence electron. Atomic number is 10 for neon. So we have 2 in the first shell, 8 in the last shell. So it has an octet configuration. So oxygen will try to get the octet configuration of neon by sharing 2 electrons. So it is having a valency. Oxygen has a valency 2. So how do you calculate? 8 minus 6 valence electron is 2. So valency of oxygen is 2. So we have a sharing of valence electron, 2 valence electron between 2 oxygen atoms. So we have a bond formation which is called as pi bond. Since 4 electrons are shared, we have 2 bonds here. That is 2 electrons which are shared by one oxygen atom is represented here. So one oxygen from this oxygen atom, the other oxygen is here. So we have 2 valence electrons which are shared. Again, 2 valence electrons of one from this oxygen, other one from other oxygen. So a shared which is represented as a bond. So one bond means 2 electrons are shared. So you have 2 bonds, that is 4 electrons are shared. So which is the pi bond which exists between the 2 oxygen atoms. It is formed by sharing of electrons, and so it is called as covalent bond. You will be learning about this in your classes, higher classes. Here again we have the hydrogen sharing the electron, 1 electron, so that it will have the complete K shell with 2 electrons. So they share so that both the electrons will just move around to complete its stability. So here we have the 8 electrons in the previous case oxygen atom. So if you count the number of electrons in the last shell, it will be 8. So this 4 is common for both oxygens. That is why we say that they share the electrons like this hydrogen atom. So valency of hydrogen is 1, oxygen is 2, right? So what is valency? Let us define. It's a combining capacity of an atom which tells us how many electrons does an atom need to lose, gain or share in order to attain a stable octet configuration. Thereby they form bond, that is they form new molecules and compound. So I'll repeat, valency is a combining capacity of an atom which tells how many electrons should an atom need to lose, gain or share in order to attain or in order to acquire the stable configuration or octet configuration, so that it results in the formation of bonding, that is formation of molecules and compounds. So we have examples here, sodium with a valency 1 and chlorine also with a valency 1. Here sodium needs to lose one electron in order to acquire its stability, and similarly chlorine has to gain one electron to acquire a stability. So sodium and chlorine will together form an ionic bond to form a new molecule called sodium chloride. Hope you followed. Thank you.